Imagine you are looking for something incredibly important, like a tiny needle in a huge haystack or a very specific pattern in a vast sea of data. What happens if you look right at it, but somehow you miss it? This is a crucial concept in many fields, from medicine to engineering. In statistical analysis, a false negative is often referred to as a type 2 error. It means that you have failed to detect an effect, a difference, or a relationship that actually exists in reality. Essentially, your test result or analysis indicates there is no significant finding, when in truth, there is one. The core of understanding false negatives lies in the framework of hypothesis testing. We typically start with a null hypothesis, which states there is no effect or no difference. Our goal is to gather enough evidence to reject this null hypothesis in favor of an alternative hypothesis. A false negative occurs when the null hypothesis is incorrectly accepted or not rejected, despite the alternative hypothesis being true. This can happen for several reasons, such as insufficient statistical power to detect a real effect, a small sample size that masks the true signal, or simply high variability within the data that obscures the underlying pattern. To minimize the risk of false negatives, researchers often employ various strategies. These can include increasing the sample size of their study to gather more data, which inherently boosts statistical power. They might also refine their measurement techniques to reduce variability and improve the precision of their observations. Sometimes, improving the experimental design itself can help to enhance the signal of the effect they are trying to detect. It is a balancing act, as reducing the chance of a false negative can sometimes increase the chance of a false positive, also known as a type 1 error. A critical concept linked directly to avoiding false negatives is statistical power. This refers to the probability that a statistical test will correctly reject a false null hypothesis. In simpler terms, it is the likelihood of detecting an effect if an effect truly exists. Understanding power is vital because it quantifies your study's ability to avoid type 2 errors. For instance, in a medical trial, a high power means a better chance of identifying an effective treatment, while low power could lead to a promising drug being incorrectly dismissed. This is an insider detail that serious researchers always consider before even starting a study. Ultimately, a deep understanding of false negatives empowers you to design more robust studies and interpret results with greater accuracy. Recognizing the factors that contribute to missing a real effect helps you refine your methodologies, from choosing appropriate sample sizes to considering the practical implications of your findings. It ensures that your conclusions are not just statistically sound, but also reflected the true state of the world, helping you avoid overlooking significant insights in your data.